Lesson 5-4, Equilateral and Isosceles triangles. If you remember, isosceles triangles are a triangle that has two sides that are the same length, like that. We call the sides that are the same length legs. We call the third side the base. So the legs are the congruent sides, the base is the third side. The vertex angle is the angle between the legs, and the other two angles are the base angles. So there's a couple theorems. The base angles theorem says if two sides of a triangle are congruent, then the angles opposite them are congruent. So I have two sides of this triangle congruent, thus the angles opposite those two sides are congruent. So in other words, in an isosceles triangle, the base angles are congruent. The converse is also true. If two angles of a triangle are congruent, then the two sides opposite them are congruent. So these angles are congruent, so those two sides are congruent. So if two angles are congruent in a triangle, then it's an isosceles triangle. Alright, so let's complete our statements. The segment HG is congruent to HK. Then, angle what's congruent to angle what? Well, here's the triangle that we have two sides congruent in. So, go to the opposite side from the congruent angles, and it looks like angle HGK and angle HKG. This angle and that angle. How about if angle KHJ is congruent to angle KJH, those two little angles? What sides are congruent? So go to the opposite side of the triangle. It looks like this side and that side. So HK and KJ. A couple more little theorems. Corollary to the base angles theorem, which says if a triangle is equilateral, then it's also equiangular. Well, think about this. If two sides are congruent, then the angles opposite them are congruent. So if all three are congruent, then the three angles opposite must be congruent. And the converse is a corollary. If a triangle is equiangular, then it's equilateral. Alright, so here's a picture. Let's find ST. Well, looking at this triangle, I see that all three angles are congruent. Thus, all three sides must be congruent, and ST must be 5, just like TU is. And then what's the measure of angle T? Well, that's cool. But if these are all the same size, then I know that 3x has to equal 180. So x, divide by 3, x must be 60. So measure of angle T must be 60 degrees. If it's equilateral or equiangular for a triangle, the angles are 60 degrees. You can just use that. It's not a theorem that we have in our book, but you can use it. If it's equilateral triangle or equiangular triangle, then the angles are all 60 degrees. Okay, there's our picture. Let's find the values of x and y. Well, let's start with x. X, I think, is actually the easiest. You see this triangle that x is a part of. Well, all three sides are congruent. Therefore, all three angles are congruent. So x must be 60 degrees. Well, then what? Well, these two angles here, so this one's 60 degrees, this one's 60 degrees, and this one's 60 degrees. Let's call this one W. I know that the 60 plus the W has to equal 90 because it has the right angle mark here. Therefore, the W must be 30. So if this is 30 degrees. But I see that in the smaller triangle, two sides are congruent. Thus, these two base angles must be congruent, and that one's also 30 degrees. So now in that little triangle, I can say 30 plus the y must equal 180. Or y must be 120 degrees.